What is going on YouTube? Just helping you out here. And for today's video, I'll be doing Chapter 22, Problem 9 in the Fundamentals of Physics textbook, 8th edition by Gerald Walker, Halliday, and Resnick. Chapter 22 is all about electric fields, and in Problem 9 we have 4 charges that are arranged in a square, and we're asked to find the net electric field that the particles produce at the center of that square. And so we know that the net electric field is equal to E of x times I hat plus E of y times j hat, and we know that E is equal to k times the absolute value of q over r squared, where k is equal to 1 over 4 pi epsilon naught, and that is a universal constant, which is equal to 8.99 times 10 to the 9th. And the units on that are newtons times meters squared divided by coulombs squared. And so what we need to do is find each of these values, E of x and E of y, and so we can take E of x first and expand it out. And so E of x is equal to E1 of x plus E2 of x plus E3 of x plus E4 of x times the cosine of 45. Cosine of 45 because we're looking for the x direction, and 45 because if we have a square, our radius is going to be a diagonal from the charge to the center of the square, and the angle that is made from the top or the side of your square to that radius is equal to 45 degrees. And so we can expand out each of those using this equation here, and that'll give us E of x is equal to k times the absolute value of q1 over r1 squared plus k times q2 over r2 squared plus k q3 over r3 squared plus k q4 over r4 squared times the cosine of 45, which is the square root of 2 over 2. And so in this expression we calculated k, and we're given in the problem what our charge values are, and so really we just need to figure out what the r value is. And since we have our particles arranged at vertices of a square, and our point of interest is the center of the square, our radius from each particle is going to be equal. So r1 equals r2, which equals r3, which equals r4. But we need to figure out what that r value is. And so if we draw a square, and say this is our point of interest, and say this distance right here is a, we'll say this distance right here is a over 2, and this distance is a over 2. And so what we can do is find our radius here from our charge to our point of interest by Pythagorean theorem. And so we can do the square root of a over 2 squared plus a over 2 squared. And if you multiply those out, this should end up being the square root of 2a squared over 4. And so if we just simplify that a little bit, our r value is going to be equal to a root 2 over 2. And in the problem we are given what the value of a is, which is 5 centimeters. And so this is equal to 5 centimeters, which we actually will need to convert to meters since our k value up here is in meters, and we're going to have a couple other things in meters. And so we know that there's 100 centimeters in 1 meter times the square root of 2, all of that over 2. And so our r value is equal to 0.0354 meters. And so now I can simplify this expression a little bit. Each of these r's I'm just going to say is r. So what we can do is we can actually take k over r squared out of each of these terms, and that'll leave us with ex is equal to k over r squared times our charge values. Now we need to think about what the sign is going to be on each of these charges. In this expression up here, I just wrote it as a generic form. These aren't necessarily all added together, and what I mean by that is we're looking for the electric field at the center point. And so we have a coordinate, we have a positive x direction, and we have a negative x direction, positive y direction, and negative y direction. And we know that charge flows from positive to negative. So we need to take into consideration the direction in which the electric field is flowing through that point from each of our charges. And so for charge 1, for the x direction, charge 1 has a positive charge, meaning that the electric field flows away from that charge. And in our figure, if the electric field is flowing away from that charge and toward the center point in the x direction, that means that the electric field is moving in the positive direction. And so we're going to have a positive sign on charge 1. Charge 2 is negative, so the electric field is flowing toward it, which is also in the positive x direction, so that's plus Q2. And for Q3, our Q3 is positive, so it is flowing away from Q3, which is in the negative x direction, so that's negative absolute value of Q3. And same thing for Q4, it is negative, so the electric field is flowing toward it, which is also in the negative x direction. So negative absolute value Q4, and we're given those in units of nanocoulombs. And then that times the square root of 2 over 2. And so now we have all the values we need to plug into here, and we get E of x is equal to 8.99 times 10 to the 9th newtons times meters squared per coulomb squared divided by r squared, which we found right here, 0.0354 meters squared, times the absolute value of our charge values, 10 plus 20 minus 20 minus 10 nanocoulombs times the square root of 2 over 2. And now, since this is coulomb squared and this is nanocoulombs, it would be advisable to convert this nanocoulombs into coulombs, but if you look right here, we actually have 20 minus 20 and 10 minus 10, so all that ends up being 0, and so our E of x actually ends up being 0, and so we don't need to do the unit conversion. And that has units of newtons per coulomb. And now we're going to do something very similar in the y direction, and so E of y is equal to E1y plus E2y plus E3y plus E4y, and this time that's going to be times the sine of 45 because we are talking about the y direction, and so in order to get us in the y direction we have to multiply the sine of that angle. To save a little bit of time, I would then expand this out the exact same way I did here. What I'm going to do is I'm just going to skip right to this step, and so we'll have E of y is equal to k over r squared times, and now we need to do the same thing where we analyzed which direction the field is flowing from or to these particles in the y direction. And so in this case, if we look back at the figure in the problem, again, Q1 has a positive charge, and so now if we're looking in the y direction, the electric field is going to be flowing away from Q1, and if we're going away from Q1 in the y direction toward the point of interest, that is going to be in the negative y direction. And so in this case, we're going to have negative absolute value of Q1. If we do the same analysis on Q2, Q2 has a negative charge, and so the field will be flowing toward it, which is the positive y direction, and so plus Q2. Q3 is also positive, and so that'll be flowing in the positive direction as well. And finally, Q4 is negative, and so that will be flowing in the negative direction. And then the sine of 45 is the square root of 2 over 2, similar to the cosine of 45. And so we have all of the values that we need to fill in this expression, and so I'm going to plug those right in. We have 8.99 times 10 to the 9th newtons times meters squared per coulomb squared divided by 0.0354 meters squared, and then times -10 plus 20 plus 20 minus 10 nanocoulombs. And in this case, our magnitude here is not going to be 0, and so we do need to do the unit conversion. And so we know that 1 times 10 to the 9th nanocoulombs are in 1 coulomb, and then that's going to be times the square root of 2 over 2. And so that whole expression is equal to EY. And so if you plug that into your calculator, you should find that EY is equal to 1.02 times 10 to the 5th newtons per coulomb. And now we have both the values that we need to plug into our E net, and so E net is equal to 0 newtons per coulomb I hat plus 1.02 times 10 to the 5th newtons per coulomb J hat. So this term is 0, so this is just going to go away, and then we're left with that other term. So the final answer to this problem is E net is equal to 1.02 times 10 to the 5th newtons per coulomb J hat. And so that's about it for this problem. If you found this video helpful, please drop a like, leave a comment if you have a question or an idea for a future video, and lastly, please don't forget to subscribe and tell your friends about my channel so I can grow and help more of you guys out. I'm just helping you out. See you in the next video.